And I'll give it just a second to come up. And I'll unmute. Did somebody have a question? No. Okay. So I'll mute everybody again. So the purpose of the training is basically you all were you expressed interest in getting this initial look at multi. Some of you all contacted me probably some months ago. Some of it may have been in response to a discussion or a presentation that Josh Olson made, possibly at the NASCAS conference or somewhere else. But anyways, you all expressed this interest in looking at multi, so we're putting this training together to kind of give you this initial look so that you can use it and begin to see if this is a tool that you want to integrate into your program. In some sense, you'll be our final beta testers for the software. So certainly if you use the software and run into any problems, we'll want you to contact us, and I'll give you contact information at the end of the slide presentation. But I think you all have gotten an email from me anyway, so you can just send me an email if you have any questions, and I'll get back in touch with you. But basically, this is, I say final beta testers, but really the software is developed and it's ready to use. And if you want to use it, you should just contact us, and we can kind of set up a state. I'll talk about this a little bit more in a minute. So this is the beginning process, essentially, for rolling out multi to the weatherization network. And as I said already, contact us if you want to start allowing agencies in your state to use multi. What we'll do is we'll set you up with a state database that only the agencies in your state would be connected to, and from there you can begin to let agencies within the state use the software, have trainings, et cetera, et cetera. So the agenda is, I hope I eventually made it clear, this is a series of trainings. We can't cover everything in one training session. So we're going to have 3 different webinars, today, and then Thursday, and then next Tuesday, all at 1 o'clock. We schedule it for 1 to 3. Hopefully it won't go 2 hours, because I know a 2-hour webinar is about as long as anybody can stand. So the first one here might go the longest, and then the second 2 I don't think will take a full 2 hours. And what we're going to cover today is I'll give you an overview of the software, of this web-based Weatherization Assistant umbrella, and then specifically I'll give you a quick 5-minute kind of overview of multi and how it works and what you get out of the software. And then I'll specifically cover what we call the agency and the user forms. Not a lot of time on that, but just a brief introduction to those. And then I'll spend a little time going into how do you create an account and how do you start an audit. And then I'm going to use a pretty simple multifamily building to go through basically all the input forms in multi to show you how you enter walls and windows and the heating and cooling systems and things like this. And when we get through all that, that'll be the end of the agenda for today. And then on Thursday, what I'll do is I'll pick up from there and talk about how you would program more complicated buildings, because the building that we chose for the demonstration today is a very simple 3-story slab-on-grade building that will make it easier to kind of go through all the forms so you can see all the forms once. And then Thursday, I'll go over a little bit more. We'll spend 10 or 15 minutes talking about how you would enter slightly more complicated buildings. And then we'll get into entering utility bills, and then actually how do you run the audit. And running the audit is kind of a 3-step process, which I'll talk about more, but it's a calibration run followed by running the audit to look at the economics and savings of individual weatherization measures, and then putting it all together into a package. And although originally the slide says that I would describe the weatherization measures and how you enter them on the second day, I think I'm going to do that today, because you do it on the forms where you describe the building. So I think it'll just make more sense to move the description and discussion of the weatherization measures into our discussion today. And then on next Tuesday will be the wrap-up, and we will talk in depth about these libraries that the audit uses to do its runs, these economic, fuel cost, and measure cost libraries. And then we'll have time for any final questions or discussion. So that's the game plan. We'll see how far we get today. Hopefully we get as far as I hope, and then we'll pick up as this agenda, shows on Thursday. So real quick, just want to say that Multi was a collaborative effort between ORNL and the Lawrence Berkeley National Laboratory, or LBNL. Basically, we did all the programming and development for the audit itself and to use it within the Weatherization Assistance program. LBNL actually was in charge of putting the API together to run the energy analysis engines, which is primarily the DO2 program. And they were also going to integrate it into a software package of theirs called the Home Energy Saver Suite. So as I said, Multi is developed specifically for use within the Weatherization Assistance program, and it's developed under what we call our Weatherization Suite of audit tools. It's meant to allow experienced weatherization auditors to easily develop a multifamily audit tool, an audit, and to get recommendations for that building. The emphasis, Minnie here is telling me that the screen froze. Okay. And so let me go back over here. So I'm sharing the screen, and she says it got frozen on the ORNL LBNL slide. It still looks like it's freezing. Never have had that happen. Huh. Now it just updated. So if you weren't able to see that slide I was talking about, Minnie tells me that it was frozen there for a little while, but I've just basically been going down these points. So the emphasis is that it is for experienced auditors. It's not really, multifamily buildings are a little bit more complicated, as you know, than single-family buildings, and it's probably not a tool to be used by a new auditor that you're just training to be an auditor. It kind of assumes some experience in running an audit, and you'll see for yourself, in the end, who you think you can bring on board to use this tool. It does address basically all types of multifamily buildings and their systems, but at this point, central heating systems and some elements of high-rise buildings, which is ventilation systems and service cores, really have not been addressed. So predominantly it's for multifamily buildings that are heated or cooled by individual heating or cooling systems, somewhat similar to what you would find in a site-built house. It does analyze a wide variety of weatherization measures. It does both heating and cooling. It does divide the building into zones. It uses a fairly comprehensive set, but fairly simplified inputs to do its analysis. And basically it uses the DOE 2.1e energy calculation engine to do the bulk of its calculations. Although there are some specialized models, for example, a slightly kind of standalone model that does the analysis of domestic water heating energy use and savings. And DOE 2 is an hourly simulation program, so the analysis is being done hourly. And I just switched to another slide, but Minnie is saying that it's not updating on her computer. I don't know why there's such a delay here. I'm going to unmute everybody. Is everybody else? Is other people seeing a lag? Right now, I've got a slide that says accessing multi.
We're not getting
Mark,
a lag.
it's working for us. We've been mentioning it in the chat.
Okay. So it is updating for some people, but not for others. I don't know why some machines are going slower than others. I don't think it has anything to do with what's on my machine. Okay, well, I'll just go ahead and you will, I think, catch up, and the slide will, it did appear eventually on Minnie's computer, and so I think it'll catch up with yours. I've got a slide that just talks about how do you access multi, and I'll send the slide presentation out to you also when, there it goes, Minnie is now updated. So somehow there's a little bit of a lag, so I'll just kind of keep going and you'll eventually see the slide. But you do need internet access. Not exactly certain. I don't think there's too much of a restriction on the browsers you use. We've used it on Internet Explorer, Firefox, Chrome. What we'll do is you'll have a URL that you'll log into, and I'll show you then the login in a minute. And when you log in right now, you'll be logging into just a database that we've been using for years here in our development process. So at this point, when you log in, you just might, I wouldn't recommend that you actually start entering a building that you will really want to use permanently in the future. If you're ready for that step, you should call us and we'll either, if it's a state weatherization program that wants to use the software, we'll set you up with a separate database, or we'll put you into a database that is kind of clean. What you'll have is a username and a password. You'll log in. You get that from us. Sometimes it might be a good idea to use the Control F5 key on your keyboard to clear the cache before you log in. Sometimes that seems to make things work a little bit better. Screen resolution, I think at one time we recommended 1280 by 1024 or above. If you go to something lower than that, you might have to scroll on some of the forms. So a little higher resolution will make it work better. And so I just moved to another form, and basically it's a screenshot of the login window that you get when you go to the URL that we'll give you. And the emphasis here is that, so what we have is what we call a web-based weatherization assistant. We actually have the weatherization assistant that is a computer-based tool, a computer-based application that that contains the National Energy Audit Tool, or what a lot of people call NEAT, or the Manufactured Home Energy Audit, which is MIA. So on the web-based weatherization assistant, we primarily have two audits. We have multi, and then we have a health and safety audit, which I'll talk about here in a minute. So basically, though, you'll, I think it's showing up now on most people's screens. You see a form like this. This is where you'll log into, and depending on your user ID, you'll be sent to your appropriate database. And then in this umbrella is how you access all the agency account, library, and audit forms to program and use not only multi, but the health and safety audit. And I just thought I'd just throw up a quick slide here to show you how you navigate through the system. And again, some of you all might not be seeing it yet, but you will in a minute. There is a set of menu bars at the top that allows you to access different sets of forms. It's a little hard to read on the screen, but you can kind of see that there's an agency menu item, a user menu item. So these are just different menus that you get into to do different things. This form that I'm kind of showing you right now is a multi-form. In multi, there is what we call an audit doc on the left-hand side that allows you to access all the different multi forms. You can see that there's a form for walls and a form for the roof. This box up at the top of the audit doc summarizes what audit you're looking at, and then there's a set of buttons at the bottom that allow you to run the audit. On some of the multi-forms, there's a set of tabs up here that are different forms. So, for example, I think I'm on a wall form right now. So basically, this is a set of tabs that says you can enter either 4 exterior walls, 2 underground walls, or 2 interior walls. So there is a restriction in multi. You cannot enter an infinite number of walls, for example. The tabs will decide how many different wall segments or wall descriptions you can enter. You don't see tabs on all the forms, but you see them on probably about half of the forms. Then basically there's kind of the main body, which on all the forms, this is the inputs that you're using to describe, say, either the wall under a multi-audit, or if you were under the agency, there would be fields here to describe the phone number for your agency and a website for it or something like that. There are buttons that allow you to create new forms or blank forms or to save what you've entered. The save ones are usually in the lower right. They're OK and apply. Cancel, of course, cancels out what you've entered and just brings you back to where you were before. And then in the lower left, there's usually buttons that either you can create a new form, or you can copy a form, or you can delete a form. And then on most of the forms, at the bottom is what we call a list view. So in this case, it says this is a wall form. So this is basically listing all the wall segments that you've entered for this specific building. If we were looking at the say the account form, down in this list view would be all the different building accounts that you've entered. So this is just where you see all the different things that have been entered in relationship to the form that you're looking at. So that's a quick overview of how you navigate through the system. And I'm just going to give you a quick overview here that in using multi, it's kind of a 3-step process to run the audit. You basically describe the building, and what most people will probably do is then enter utility bills and then do what we call a calibration run. And when you do the calibration run, you will look at the calibration results. You will compare where it compares the predicted energy use to utility bills. If the comparison does not meet your standard, you will go back into the building and make adjustments, and you will continue that iterative process until the building model has been calibrated. At that point, you will do a run where you look at the energy savings of individual energy measures applied to the building as you've selected them. And then what you do is after that run, this is where you actually cost out the individual measures that you wanted to be analyzed and look at their economics. And then you pick which measures you want to put into a package. And once you've done that, you will then go into this third run, which is the package run, where we analyze all the measures applied together in this building as one package. So basically, the run process is describe the building and then do a calibration run, analyze individual measures to see which ones you might want to apply to the building, make your selection, and apply them as a package. Today, we're pretty much just going to spend time on how do you describe the building, and next, on Thursday, we'll go through this run process. Okay. Somebody was saying it's a little hard to see, so let's see. Now that put it over to a different screen, so I got 2 screens and it's not sharing it to the right place. So that wasn't too successful. So I don't really have any more slides here, I don't think. So I apologize if you weren't able to see the slides or see it all, but I'm basically about done. So, so at this point, I'm going to unmute everybody and see if anybody has any initial questions, and then I'm going to go right in and give you about a 10-minute overview of the software. So some of you all might have muted yourselves. If you have, I think you'll have to unmute yourself individually, but I've unmuted everybody that I can unmute at this point. So if anybody has any questions, just go ahead and ask.
We're good. We don't have any questions right now.
Yep, doesn't look that way. All right, so I'm going to mute everybody again, and I am going to go right into the audit then. So I'm going to pull the audit up, and at this point I've already gone through the login process. So I didn't actually show you how that worked. Basically, that screen that you had the user ID and password, you just would have entered that, and you would have been brought right into here. I think the default is that you're brought into, as a default, an existing multifamily audit. Okay? And as I said, there is this list of kind of a menu list up here that allows you to see different forms. You can look at an agency form, an account form. I'll go to one of these. Here's the agency form. So this is just a form that kind of describes what agency are you, what's your name, where are you located. I'll go over this in a little bit more detail after I do this overview. There's a user form or menu item that allows you to enter other users of the software. So if we get one person set up in an agency and they want to enter another auditor, then you can do that on your own. You won't have to contact us. Libraries are used by Multi, and I'll cover that in the third day. There's basically an economic library, a fuel cost library, and a measure cost library that you can set up to these two are needed to do the analysis. This one is optional, but it's there to make it easier for you to, or your auditors, to cost measures out so that they don't have to do hand calculations every time. And the account form is where you end up starting, and again, I'll show you this in more detail, but basically you set up an account. For this little demonstration, I think we have an agency called ORNL, and I'm actually going to I'm going to use this audit that we call WX, and it was, anyways, we created an account called Sample1 account. So we created an account called Sample1 account. It basically describes where the building is and a few other things. And then we went over here actually to Multi, and we created a Multi audit for it. So again, I'm going to spend the rest of today kind of showing you how to do all this. But let me just kind of quickly show you how all this works so you have some idea of where it's going. What you would do is that you would fill out pretty much all the forms on this side in the audit doc. The ones with red circles are mandatory forms. You have to fill out the audit form, the building form, the wall and the window form, the HVAC and the infiltration, and lighting and these down here too. But there are some forms that are, quote, optional. So if you wanted to run a building with no doors or no roof, you could actually do that, although in practice you probably never would. So so what you will do is to enter a building, you'll go through all these forms and describe the building. Pretty typical audit stuff. And once you're done, you will probably, to do the calibration, you'll probably enter utility bills under this utility bill form, and then you would do what we call a calibration run. And I'm not going to go through the process right now. I'm just going to click on the calibration report to show you what you get after the end of a calibration run. And this will take a few seconds to come up. We're working on, and we're going to get this so that it loads up faster. especially in a demonstration. I think it's just about there. Are you seeing this, Minnie? Yeah. So I'll get this to fit so the calibration report, the first page just basically summarizes what building it is and what the account was and what the audit details were. And then there's a form that will print out what the estimated energy use of the building is. There's one page for electricity use, and if the building used natural gas for heating or water heating, there'd be a second page that would give you natural gas estimated consumptions. We provide that in a table as well as a graphical look. The energy use is given by the total, so this is total electricity use for the building, and we divide it up into the primary components of heating, cooling, water heating, appliances, and lighting. And then what we do, if you enter utility bills, then we compare Multi's estimated, in this case, electricity use to what the electric bills were, and we do that in table form as well as a graphical form. And then at this point, the way Multi is at the moment is you would look at this comparison and decide if, I think the orange line is what the utility bills were, and this dotted line is Multi's estimated electricity use. You would look at that and decide, is this close enough to you to think that you've got the building properly modeled? In this case, you might look at the summer data and say, well, it looks like we're overestimating the cooling use a little bit. Maybe we don't have the efficiency right on the air conditioners or something, and you would go back and tweak the input, rerun the calibration run until you were satisfied that you had modeled the building as well as you could as it compares to utility bills. And there is a fourth page to this because we also, as part of the utility bills, if you know, for example, the heating degree days or the cooling degree hours or degree days that corresponded to the utility bills, if you enter that, we'll compare the utility data used in our analysis, which is a standard weather year. We'll compare that to the weather that was that occurred during the utility bills, so that you can begin to see if this difference, for example, here, might have been due to the fact that it was a warmer or cooler summer than what we assumed in making the Multi estimates. From this contrived building that we entered, we made the weather pretty much agree with that the utility bills experienced. It pretty much agreed with our standard weather in our software. So pretty much you'd say, it wasn't the weather that caused this difference. It must be something going on with something in the building that we don't have possibly, entered right, or we have some uncertainty. But that's basically the idea. Is you would run this calibration run and look at these results and tweak the input until you were satisfied. Once you were satisfied, you would then do what we call a measure run. And let me just kind of show you, when you're done with the measure run, you will get a set of 4 tables that presents to you the analysis of how much energy is being saved by individual measures as they're applied individually to the building. So at this point, although we've listed 8 measures here, for example, what we're doing is that we're saying, well, let's replace the existing windows with whatever window I said to replace it with, and let's see how much energy this saves. And then let's replace the door, and then let's do the air sealing. And what we're showing you is the savings, and in these other tabs, we'll show you the economics of those individual retrofits applied to the building individually. So in this first table, we basically summarize the energy savings by component and total for electricity and for natural gas or fossil fuel. We then convert all that into cost savings. So this is the total cost savings for each measure. Here's the total cost savings for the measure, and it's also divided into the different components. And then in this measure run, here's each measure, and this is where you cost out each measure. And basically there's two columns here that allow you to pull from what we call the measure cost library, costs that you've entered into the library to help you estimate the cost of this measure. So for example, for a window, you might have already entered the cost per united inch of a double pane, low E, high solar window. And if you want to use that cost, you would select it here, and then Multi would calculate the cost of that measure based on that measure cost library. If you don't want to use what's in the measure cost library, you can always opt out and say, I don't want to use it. And you always can put in what we call an adjustment, so that if there is no cost in the library, you can just put in your own cost, and then that becomes the total cost. I probably should have shown here an adjustment. I didn't do that, but if you had put like say $1,000 in this row, the 1,000 would have been added to the 3,888 to make this 4,888. So you can use the cost in the measure cost library to get you started, or that could be your final cost, or you don't have to use it at all and you can just enter cost directly. Once you've entered the cost, you go to the fourth tab, and now we kind of present a summary. We show you for each measure how much was this going to save in dollars, how much was it estimated was going to cost, what's the lifetime of the measure, what's the SIR for the measure, and what's the simple payback. Now, at this point, you would, and at this point, you could actually analyze different window retrofits that you actually, couldn't do simultaneously in a building. You could look at replacing the window with something. You could say, well, let's put a storm on that window. So you can do multiple measures. And it would be at this point that you'd say, well, okay, but which of these do we want to put into a package? So as an auditor, you would use your best judgment. You might talk to the building owner. You eventually come up with what do you want to put into a package. You might actually iterate this and create one package and then kind of create a second package. So this is also going to be an iterative process. I notice right now, normally there would be some check boxes here that would then say, I've selected these different measures. We've already run this, and oh, no, we didn't. Oh, I know why. Let me go back up here. I think when I jumped out of this and came back to it, I didn't go to the audit that I actually had run this. So I apologize for that. This was the audit I was going to show you in this quick demo. Everything I've talked about is the same. But just let me go back to this measure cost. You can see that for this building, we put in about 19 different measures, and we selected a certain number of them. We didn't select all of them. We might not have selected ones that were economical or whatever. But in the end, we picked a certain number of these to put into a package, and those are the ones with the check boxes. So when you're done with that, then you do what we call a package run. Again, I won't go through the whole process. I'll just click on the button where we have the results. And again, you have 4 different tables to summarize the results of this package run. In this case, for the energy savings, what we did is we apply the measures individually in decreasing order of SIR and then recalculate the savings for each measure as it gets applied to the building, so all the interactive effects get analyzed. So these are the 14 measures that we must have selected under that previous form. At the bottom, though, there's a package summary. So basically, you can see on this is the energy savings table. You can see the energy savings of the individual measures as it's applied to the building as a package, divided into the different components, and we divided by electricity and a fossil fuel. And in this package row, you can see the total. What's the total savings for the building? We then convert all that into dollars. So here's the dollar savings. We then look at the economics of this, and we show you what the final SIR is for each of these measures as it's applied to the building, as well as the package. So in this case, the package SIR is 1.2. And then there's a final form that says, okay, if you want, since some of these measures had an SIR below 1, maybe you analyze them because the building owner was going to help pay for them. So what we have is a column that basically says, well, how much would somebody have to pay to get this SIR up to 1? How much is somebody actually going to pay? Therefore, how much is what's the program cost? Basically, the total cost minus what somebody else is going to pay for. And then we recalculate the program SIR based on this leveraging adjustment. And basically, you can see this on the form, or you can click a button up here and see this in a kind of a printable report format. So I'm going to get out of this, and basically that's kind of the quick overview. So when you run an audit, you're basically describing the audit and then going through this run procedure so you can finally see these final package results, and that's kind of what you're trying to get to. So again, with that, I will unmute everybody and see if anybody has any questions. And after this, what I'll do is I'll start going through a little bit slower and just talking briefly about the agency, user, and account forms, but then basically getting into the multi-forms and spending about an hour and about 5 minutes a form just kind of talking about each form. So any questions about basically what multi looks like or where it's getting you to?
None yet for us.
There was a question in chat about utility bills.
Yeah, I see there's a question in the chat that says, what would be considered an acceptable percentage difference in utility bill and estimate? There is some guidance for that, which we can refer you to. I'm trying to remember. It's in a guidebook that we're developing. I think at one time we were thinking of putting it actually these percentage calculations that you can calculate right on the forms. I don't remember, but there's I think it's either like ResNet or BPI, and there's a few other organizations, ASHRAE, that have some guidance on this, and I can get that guidance to you. I know we discussed it somewhere, and I don't know if it's in that. I sent out that 20-page Getting Started guideline to everybody. I don't remember if the reference is in there. I think it might be. But if it isn't, I can give that to you and give you some guidance on what constitutes a good estimate. But in the end, it's going to kind of be a little user. It's going to be up to the user to decide. These numbers might be some guidelines, but in real buildings with real utility data, sometimes you're not ever going to get things exact, and at some point you're going to say, well, I just can't change the input anymore to get the answer any better. I've changed the input as much as I realistically can, so at some point it's going to be up to the user to decide this is just as good as I'm going to get it. All right, I don't see any more things under the chat, so I will go back. And so to kind of start off, and now at this point, you might want to follow along. I sent that user guideline out. Let me kind of get it up here. Remember, I sent out this, we put together this Getting Started guideline. And to some extent, I'm going to kind of go through this guideline now. We've already kind of gone through some of these preliminary pages talking about how you log in and what the general layout of the forms looks like and things like this. And pretty much I'm going to skip down. Where you might want to start up here then is right here, I think, where I talk about the Oops, right up here. I am going to talk a little bit about the user and agency forms. I'm going to skip the libraries. We'll talk about that on a week from today. And then I'll go right into the account form. But if you wanted to, you might want to kind of follow along with that guideline, or know that, you know, at the end of the day, when I'm done talking, you should probably read through this guideline. It's going to say a lot of the same things I'm going to say, probably say them a lot clearer, reinforce what I've said, throw in some additional details. But the guideline was kind of written to kind of get somebody started. Mind you, 20 pages is not going to answer every question on every field of how all the perturbations that you might encounter and whatnot. But the guideline is kind of there to at least get people started to use the software. And once you start using it, you can kind of generally, it's pretty intuitive. You can see how things work. You can see what the options are for different fields. And then if you have specific questions, you can begin to call us. All right, somewhere my mouse is around here somewhere. There it is. So I'm going to go right into multi, and the first thing I'm going to do is talk about the agency form. Again, simple. Everybody belongs to an agency. I just set one up, I think, for ORNL, and so what you do is you say, hey, my agency is ORNL. I'm located at 1 Bethel Valley Road. You can list phone numbers and stuff if you want, but you basically do got to get an agency name in there that we can reference things to. When we set you up with a user ID and a password, we'll probably set up an agency for everybody. Those of you all who are within the same agency will only set up one agency for you, but everybody will be associated with an agency. But we'll only put the agency name in probably, whatever's the minimum, and make it active, and then you can go in and update all the other information if you want. The other form I want to quickly talk about is users. So as I said, we'll set you up with a user ID and a password. There are different levels of a user. We have site administrators who are myself and Minnie and Gina, who can look at everything. And then we have what we call an agency administrator, somebody like who would be somebody, this person might be the person at a weatherization agency who's in charge of the weatherization program. So they would be the agency administrator. They can see everything regarding their agency. The agency form, users, libraries, all that. So that agency administrator will be allowed to go in and create other users. And those users might be either what we call a lead auditor, an auditor, or a guest. An auditor, obviously, is an energy auditor that you want to allow to be able to go into the software and enter a building and accounts and do runs. But what we've learned from our other software is that in general, there should only be 1 or 2 people that are able to set up these libraries, these measure cost libraries and these fuel cost libraries. So what we did is we created a special auditor that we call the lead auditor. The lead auditor can look at the libraries and change them, but a normal auditor can't. They can look at them, but they can't change anything. And again, an agency administrator can look at the libraries as well. So in the guideline, we talk about these different levels of a user. A guest, for example, can only look at things, and they can only look at an audit. They cannot look at anything else. Since this is kind of designed for the Weatherization Assistance program, there is a state administrator user level privilege that would allow people at the state level to then be able to go into and look at all the different audits in their state and look at all the agencies in their state and look at audits. Now, they can't change anything, but they can look at everything. So you do all this under this user form. So when we send this out, you'll have a user ID and a password. For those of you who are there's multiple of you at the same agency, I think we'll send it out to you as agency administrators, but if you wanted to play around with it and just create a user ID that's just an auditor, you could see how that works. So the way you really start, though, to enter a building to audit it is you go to the account form. And at this second, I do want to bounce back to my PowerPoint presentation just for a minute and talk a little bit about creating and viewing these audits. So I got 2 slides on this. So basically, to create a new audit, of course, you always log in. Make sure you're connected to the right agency, although if you're only connected to one agency, you will only be able to see the buildings in your agency. And basically what you do is you create an account and you create an audit. And to kind of show you how this works, we've got this very simple example. So let's say that there was a Magnolia apartment complex, and in that complex there were 2 building types, building type A and building type B. There's 2 ways you could approach this account audit name thing. You could create an account called Magnolia Apartments and then create 2 audits for that account, one for building A and one for building B. However, if this is easier for you to understand, another way would be the account name might be Magnolia Apartments Building A, and then the audit name would kind of have the similar name, Building A. So if you wanted to, each account could be a separate building, but in reality, it doesn't have to be. An account could represent a complex, and in that complex, there are different building types that you want to run an audit on. So, a lot of multifamily properties, the account name, since it's only one building, the account name and the audit name would probably be very similar to each other. But if you go into, say, a public housing authority property where the housing authority has got 5 or 6 different building types, well, the account name might be the housing authority, and then you would just run audits for different building types, however you want to get it organized. And then basically once you create an audit, when you log into Multi, you can reselect any audit that you've already looked at. Just note, as I've kind of skipped ahead here a little bit, but so remember we talked about agency. Basically, you only set up the agency once. You might go in the first time and update it with current information beyond what we put in, but you probably only do that once. You do create these separate accounts to identify different projects, and then as I've said, you can run multiple audits for a single account if that's the way you want to kind of look at things. So with that, let me just quickly go back and now what I'm going to do is for the rest of the hour here, I'm going to talk about this sample account 0. I think I sent you out a building description. It was 3 pages long of this what we call this demonstration building or sample building 0. It has 3 pictures on the front that shows you what the building looks like and all. And so what we did is we created this simple account that just said, well, we're going to call this account sample account 0. We gave it an account number. We really didn't fill in the rest of the fields because we didn't feel it was, really necessary, or we didn't really have a true address, so we didn't spend the time doing that. So basically, you start by entering an account. You can see that we have lots of different accounts currently in this database of ours. So if you wanted to see a different one, you can just click on it, and it brings up the new account, or you can click at the one that you were working on. Once you create the account, that's when you go to Multi, and now you can enter an audit for that account. Now, in this case, we already have an audit for that account. You can see it's ORNL sample 0, so I'm going to click on that to make sure that's the active one. If it wasn't the active one, you would just select it. If you were doing this from scratch, and in reality, at this point, you would come in to Multi and you would click the New button to get a blank form, and then you would create a new audit for this new building. I'm not going to, in this demonstration, I'm not going to enter things from from scratch just because it would take too long. We've already entered the sample building into multi, and I'm just going to kind of go through and show you how we did it. So if you look at the handout that I gave you, that's 3 pages. Let's just look at that real fast and just kind of get an idea of what this demonstration building or this sample building 0 is. You can kind of see it's a 3-story building. There's basically just one apartment. Well, there's 2 apartments per floor, one to the right of the hallway and one to the left of the hallway. And the bottom picture shows you the bedrooms and all, which really isn't important for the audit, but it just helps visualize things, and we show other things like where the windows are and things like this. And if you look at the second page, under the general characteristics, you'll see that it's located in Boston, Massachusetts. And there's some descriptions here. There's 6 units, 2 per floor. What we call a double-loaded hallway, which I'll explain in a second. It's kind of a box shape. There's 7,740 square feet total. Since it's 3 floors, divide that by 3, and you can see what the square footage is. And we kind of said it's located on a lot that used to have asphalt all around it. So those general characteristics are basically going to be entered either on this audit form or the building form. So looking at the audit form, you can see that we called, remember the account was SOOO. This word client, this should be changed to account. It's a holdover from a long time ago, and I can't believe that we missed it and didn't change it. But the account name was Sample Account 0. We gave the audit name Sample Audit 0, kind of the same name. You choose over here who the auditor is. These gray fields are being automatically filled in because they're getting pulled in from information from the account. And then basically here you select the libraries that you're going to use to run the audit. We send the audit out with some default libraries for all the different fuels, which are average cost for the nation for whatever year we're saying over here is. We need to update that for 2017. Right now, I think the only costs we have in there are for 2015. But you can certainly, a week from today, I'll teach you how to develop your own libraries that you would probably use for your audits, as opposed to our default ones that only give you typical costs for the nation. You pick the weather station that you want to use to run the audit. There is like 1,000 something different weather stations in the database. So basically, you would probably use a weather station from your state, but you could use an adjacent, if you're right on the border of a state, you might use a weather station, say, across the state line. So you'd pick the state first, and then the weather stations for that state are then shown, and then you pick which one you want to use. Then you pick an economic parameter library and a measure cost library. Economic parameter library, I'll go over all this more in a week, but it's basically economic parameters that are used in the economic calculations. You generally won't change that. You'll generally just use our default economic parameters. But you probably will definitely develop and use your own measure cost library. And for this demonstration, I actually created a measure cost library I called Sample 0 Measure Cost Library. And what happens there is that when we get over to that part of the run where we want to cost the measures out, you can pull the different costing information out of the library to help you do that. And we'll go over that. Again, that's on next Tuesday. We discussed that. So on this audit form, there's just some general information that you enter, some names, auditors, you pick the libraries, and then you're ready to go to the building form and start entering that. So I will unmute everybody again and just see if anybody has a quick question on this audit form. I don't see anything in the chat. All right, doesn't sound like any questions on the audit form, so let me just jump over here to the building form. Now, the building form is probably one of the more complicated forms in multi. You really have to get the information on the building form entered correctly, because depending on how you enter information up here, it does then ripple through the rest of the audit to determine in some tables, for example, what rows it's going to show you and different things like this. So it's important that you spend some time getting this form filled out right and making sure it's correct before you then move on to all the other forms. You might be able to go back in here and change some of this without it impacting the other forms, but there are a few things that you probably can't change, because if you change them, the other forms don't get updated, it's not going to get created right, and you basically would have to almost enter the audit again from scratch. So the building form is really important that you get it to be accurate. So when you're starting a new audit, I didn't emphasize this enough, you almost always start by filling the audit form out first, and then the building form you would fill that out second. And for the building that we selected, our sample building, it's going to be pretty easy to fill this out because we said that the sample building is a slab, and that makes it a lot easier. And it's a pretty simple construction, so it's not too difficult to fill out. So up here you tell us how many units there are in the building, 6. What's the total area of the building on all the floors? 7,740. There's 3 stories above grade and none below grade. The average floor height is 8. Somewhere we probably said that there's 12 occupants in the building, but only 3 there during the day because the rest of them are working. The elevation of the first floor above grade is 0 because it's a slab, so the first floor is at the ground level. There's no part of the building below grade because it's a slab, so that's a 0. You tell us some stuff about, what surrounds the building, and this is this idea that there was an old asphalt parking lot around this building and that it's in some kind of a heavy urban or suburban area. You tell us what the building shape and the hallway configuration is, but we don't really use these for anything. It's just kind of there to get your thinking straight. So the options here are, is this building kind of like a linear line, or does it kind of form an H shape or an L shape? Again, it's not going to be real important what this is in the end, but by forcing an auditor to kind of think about this for a second, it gets their thinking straight. In our example, our building is just kind of a very simple linear looking thing, so we chose linear. And in our configuration, the hallways are what we call double loaded. That means that there is a conditioned unit on either side of the hallway. Okay? It might be single loaded, and I think we've got in our guideline a little picture of that. Or it could be kind of a hallway that kind of surrounds a core. But in the end, we do want to know whether the hallway is conditioned or not. And in our case, the hallway we said is unconditioned, so we don't check that box. The orientation of the building, if you're following along with me in the guideline, the 20-page guideline that we handed out, go to page 11. And there's a little description there of what do we mean by this building orientation. It's basically related to a DO2 input that basically wants to know the direction of the back of the building as it relates to north. But I think if you look on page 11 of our guideline, there's a picture and a discussion that will explain how you fill this out. We want to know the degrees. And then the next thing you need to fill out is this column over here. What this is it's showing you, it's describing how many apartments are there on each of the either first floor above grade, top floor, intermediate floors, or in the case of basement buildings, first floor below grade. If you go to our guideline and go to page 12, we show you some examples of what we mean by this, and I think once you look at the examples, you'll begin to understand how this works. I'm going to call up this guideline and go to that page and just kind of work through this real fast. So on page 12, and I'm just going to kind of go through this example. This is a building that almost looks like this demonstration building that we're doing here in this training. But in this case, it's a two-story building. And notice there's kind of on each floor, there's an apartment at the front and the back on the left side of this open hallway. And similarly, there'd be two apartments on the front and the back to the left of this open hallway. And what we're describing here is this. You see for this unit, let's just pick this unit right here that's in yellow. It has basically three walls. Since this is an open hallway, it's an open breezeway, there's three walls that are exposed to the outside. The wall to the left, the wall to the back, and the wall to the right. And on the first floor, there's actually two of those. So this unit is exposed on three sides, and this unit is exposed on three sides. Same thing, open hallway, back, and to the left. For that unit, it has three sides exposed. So those two units are described in this column on the first floor. There's two units right here where, see that dark line is showing you which of the walls are exposed to the outside. And you would type the number 2 in that box to say on the first floor there's two units with walls exposed to the outside that look like this. Then if you look up here, these two units that are to the front, this one and this one, they have exposed walls on the left, the right, and the front of the apartment. Again, the left, the right, and to the front. So those two are being described by the entry here. And then, similarly, on the top floor, since this is only a two-floor building, you only have a first floor and a top floor, you have the same numbers. So I'm not going to go into this in this brief, and again, this is you may think this is a two-hour training today, 3 of these, 6 hours, but we don't have time in this training to go over probably any more discussion of this right now. But I think if you look at this guideline, kind of look at this simple single-story building that's on a quad, you can kind of see how these things are being entered. Just to kind of give you one more example, in this one-story building on a slab that has a quad, these two apartments that are right in this wing, these two inner apartments, they have outside walls that are exposed to the right and to the left. And these two also have walls that are exposed on the left and the right. So there's 4 units that basically look like this, where there's an exposed wall to the right and there's an exposed wall to the left. So that's kind of what's going on here. And if you go through all these units, slowly on your own, you can probably see how we entered it this way. So once you enter that, use this set of boxes to say how many units are there, how is their exposure to the outside, and how is it divided between the first floor, intermediate floors, and the top floor. You enter this, and then that gets summarized into this section that says in the end, there's 2 units on the top floor, there's 2 units on the intermediate floors for our building, and there's 2 units above grade. Because remember, this example, we've got a 3-story building. And then what would happen is you would come in here and this table would be empty, and you would fill out for this table what is the floor areas on each of the different floors, A1, A2, A3. This is the first floor, the second floor, and the third floor. And it's divided by what's the floor area for the units themselves. If there's any hallways, what's the floor area for them? And then you can describe the floor area of other conditioned spaces other than the units and other unconditioned spaces. And that's because, remember, it's a multi-zone model, so there are different zones in the building. So you would then enter that information in this table to get the areas correct. So you can see that you do have to spend a little time beforehand thinking about how you're going to enter the information on this building form. You kind of have to get a strategy, you kind of have to do some sketches, and it is important that this kind of be correct and entered initially correctly. So with that, I'm going to unmute people and see if there's any questions. Let me see here. There's a question that says, the audio just went out. Is it happening on anybody else? Can everybody else hear me?
Yes.
Okay, so other people are hearing us. The question is other conditioned spaces, could that be like common areas? It might be more, I think the answer is yes. If it's a simple multifamily building, yes, it could have kind of an area that's common that might not be units. It might be a laundry room. Is that kind of good, Minnie, to describe what other conditioned areas might be? Offices, Minnie says, there might be a small office in a multifamily building. Those are all kind of common areas that would be conditioned. All right, I don't see any more chats. Oh, somebody up here, it was further up. I noticed you can only enter 4 walls. No, so what about bump outs and contemporary style buildings? This is, on this building form, you're just kind of describing buildings with these general, or units with these, orientated in these general directions. Obviously, if you have bump outs, then you have portions of the wall still facing the back and the front, but I think the answer is, without getting into a specific example, is that these are kind of general. When we get to the wall form, I think you'll see that you can actually, you can enter 4 different wall types, and you're not entering, just 4 different walls, okay? All right, so I'm going to mute everybody again, and I'm going to go on here. So that's the building form. And let me just kind of look through my notes to see if I kind of covered everything. Okay, so now I'm going to go to the wall form. And the wall form, notice this is the first form in multi that has these tabs. So basically you can see that you can enter 4 different exterior walls, 2 underground walls, and 2 interior walls. Underground walls are used with buildings that are on a crawl space or basement, and interior walls are you use when you have other unconditioned spaces like hallways in the building. You will always have exterior walls. Now, you can describe 4 different types of exterior walls. So if part of the exterior walls were wood frame and part were block, you might describe the block walls under exterior 1 and the wood frame under exterior 2. Notice, though, that for exterior 1, for a given wall type, let me kind of scroll up here so you can see this better. So for a given wall type, which we have said, hey, this wall is, there's a wall type where the wall is 8-inch concrete, you're able to say, what is the wall area that faces the back of the building, the front of the building, the right of the building, and the left of the building? And even if you have a building with what one of the participants called knockouts, you could still add up how much wall area is facing the back of the building versus the front versus the right or the left. The only time you get into a problem is if they got some kind of a angle to the wall, like on some walls where it's kind of bumped out of the living room. There might be a little angle. You'll just have to consider those either facing the front, the right, or the left, for example, for that building, and know that it's just a little off, but nothing lost too critical. So you're not entering a wall segment, but you are summing up how much wall area is facing the back of the building versus the right, the front, and the left, and then here's the total. So basically in this wall form, you'd come up and say, you give it a wall code, a name, you tell us what the construction material is. There's a lot of different options for concrete and wood walls and things like this. Depending on your selection, you'll see that a lot of times some fields get ghosted. That means those fields aren't pertinent for this construction type. If you had selected wood frame, then we would want to know what's the stud size and the spacing of the studs. But for concrete, that's not applicable, so those get ghosted. Then we want to know some information for this wall. Well, where's the insulation? And for a concrete wall, there is no cavity insulation, so that's blank. But there could be exterior or interior insulation. If you say none, then there's no insulation in those areas. But if you said that there was, you can see also ghosted out here a little bit. You would then tell us either the thickness or the R value of that insulation. If you tell us the thickness, we'll calculate the R value for you. If you calculate the R value, we'll kind of convert it and tell you how thick it probably is. We want to know what's on the exterior of the wall, and then as I kind of jumped ahead, you then would enter for all the different spaces, how much wall area for those spaces faces back, right, front, and left. And for our simple building, you'll be able to see that, most of the wall area is attached to the units, but there is some of the wall area that's attached to those hallways that are unconditioned that face the back and the front of the building. In the end, there's 5,568 square feet of wall area. Now, at the bottom of each of these different forms, basically for the shell, the system, and lighting, is not only do you describe up here the characteristic for, say, in this case, this exterior wall, but you also select what retrofit measures might be applicable to this wall that you want to analyze. So in general, there's three different retrofit measures for walls, putting in cavity insulation, exterior insulation, or interior insulation. For this concrete wall, cavity isn't applicable, so we ghost it out. But if this were a 2x4 wall, say made out of wood, then this row would be activated and you can see it. What you would do is then if you want to analyze this as a retrofit measure, you would check the active box, in which case then you would have to say, well, what type of insulation would you be adding to the exterior, and what's its R value or what's its thickness? For this example building, we said we're not going to analyze wall insulation, so we did not check these check boxes for these retrofits. And then for this building, we did use interior one walls. And you can see down here in this list view that we've entered two different walls, something that we call wall 1, which is on the exterior 1 tab, and wall 2, which is on the interior 1 wall tab. So if I go up to this interior 1 wall tab, what this interior wall is these are the interior walls that separate the unit from the hallway. If I go over here to my building, these interior walls are the walls that separate these units from this unconditioned hallway here that we have running down the middle of the building. So you would enter that under this interior 1. Again, you can see that we said in our description that these walls were made out of concrete block. This is how the areas are. They're all of this area is between these conditioned units and these unconditioned hallways. So we put that area of that wall here. We don't have any unconditioned attics or crawl spaces that are walls that separate them, so these are 0. And then again, for this wall, if we wanted to do a retrofit to that wall, we could say, hey, we might want to analyze this so we can see how much it saves, and if it saves a lot of energy and it's cost effective, we might select it for our package. But if we analyze it and the savings are low, then we won't select it for our package. But it's not going to get analyzed unless you check this active box. So that's the quick overview for the wall form. And I'm going to unmute everybody to see if there's any questions. And I don't think I see any new chat questions. And again, the best way, in this training, but this is almost more of an overview than a field-by-field training. When we're done with this in these 3 sessions, you might want to take this building and enter it yourself to kind of get used to filling out the different fields, and you'll be able to look back. And what we'll do is we'll send you not only we'll send you a handout that has how we entered all these different forms for this building. And then we'll also at the end send you copies of all the different calibration reports, measure report, and package report, so that if you program this on your own, you can see if you programmed it the same way we did as kind of the learning method. And when we're done with this next Tuesday, we'll also send out a few other example buildings. We'll send out a description, pictures, input, and all the results of all the runs, so that if you wanted to kind of try one of these other buildings that we've got that we've used, you can try to program them on your own comparing how you input it to how we did as kind of a learning method. And then maybe, after doing a few of these example buildings, you might want to go off and do your own building, one of your own. Just for example, when we train people on how to use our single family and manufactured home audit tools, Neat and Mia, it usually takes us 3 days to train auditors and go through all the different fields and talk about them in all their complexity. So you can see we don't have time to do that here in this webinar. So I know we're going a little fast, but the idea is just to kind of give you a general view of how this works. All right, I'm going to mute everybody because I don't think we had any more questions. So now I'm going to jump over here to the windows. And if we look here real fast at our handout, I'm going to jump down here a page, and you can see that our windows, we said there's a 60 by 48 window that's W1, and W1 windows are in different places here. There's one, and I think I think that's it. W1 is just here. And then there's W2 windows here, here, and here, and here. And what we said is that the W1 window is 60 inches by 48. The W2 window is 36 by 48. We kind of tell you what the window type is and that they have blinds. So we kind of give you some information there. So let's see how did we program that up into multi then. So in multi for Windows, you can see that we programmed it up as 2 window codes, Window 1 and Window 2. Window 1 is these 60 by 48 windows, and you can see we chose that they're single pane, clear, wood frame. Let me talk a little bit about this leakiness. The leakiness field is something kind of unique to these ORNL type audits, where we ask the auditor to describe the leakiness of the window. And by doing so, we then, when we analyze window retrofits, we credit those retrofits with savings, not only from making them more, improving their conductive losses, i.e. making them go from single pane to double pane, and that gives them a higher R value. But if the existing window is pretty leaky and you put a new window in, not only are you going to get a higher R value for the window and the frame itself, but you're going to reduce the air leakage of the building somewhat by putting in this new window. Well, the only way, though, we can calculate all that is if we know how leaky is the existing window right now. So what we do here is when you tell us that it's a vertical slider window, we tend to say, well, as a default, vertical slider windows tend to be tight. But the auditor needs to assess how leaky the actual windows are, and instead of them being tight, you may decide, well, they're really medium leakiness or loose. We have guidance for what these different names mean, but we also not only let the auditor choose what it actually is, but this default is just to kind of say, typically in a typical multifamily building, a vertical slider is tight. It's not very loose. So as a starting point, you should start from here, and then the auditor would say, is it a little bit looser than that or a little bit tighter than that? There's options here for describing if the existing window's got a storm or interior or exterior shading. I think we had said in our little description that there's all these windows have got blinds. And then what you do in this table here is describe for units and hallways how many units are on the different walls of these different walls. So remember we had an exterior one wall that was on both the units and the hallways. None of these windows are on the hallways, so that's why they're all 0. And if you kind of look at our diagram, there's 6 of these windows that face the front of the building. And then again, just like for walls, here's the retrofits that you can do for the windows. You can replace the window, you can add a storm, you can add shading, you can add an awning. What we said is that we want to consider replacing these windows, so we checked this box. And then when we did that, you need to enter, well, what would you replace? What is your replacement window? There's 2 ways you can do that. You can either check this box and say, well, I know what the U value and the solar heat gain coefficient for my replacement windows are, or I don't really know what those are, in which case you don't check that, but you say, I'm just going to replace it with a double pane, low E window that's designed for high solar areas. And that's basically the same as when you describe an existing window, you can put in what the NFRC ratings for that window are. For an existing window, you usually don't know them, so you don't check that box, and you just kind of use these descriptions to say, what type of window it is, and then from these descriptions, we calculate what the U value and the solar heat gain coefficient are, and that's what goes into the DOE2 model. So for this window, we said, well, let's see if replacing it, we want that to be analyzed. And then for window 2, we did basically the same thing. These are the 48 by 36 windows. You can see that there's 12 of them to the front, 12 of them to the front, 12 of them to the back of the building. Again, we said, let's analyze a retrofit to them. And just kind of jumping ahead, doors is pretty much similar to windows. So I'll just kind of cover that real fast. You can see you type in the size, you type in some descriptions of the door, you tell us where the doors are, and then at the bottom of the form you can say, do I want to analyze a retrofit for that? In this case, we said, yeah, let's see if a replacement door is cost effective. And then if you check that box, we told you what kind of a replacement door, what's the characteristic of the replacement door. So again, I'll unmute everybody and see if anybody has questions about windows and doors. All right, I don't see anything. So, and I'll maybe speed up here a little bit. We only have about 30 minutes left. For the roof, basically there's three sets of tabs up here. You can enter 4 different types of attics. These are kind of like attics that you would find, with a built-up truss system. You can enter 2 different types of cathedral ceilings and 2 different types of flat roofs. In our example, the attic was a typical pitched, attic made out of trusses, so we chose attic 1. We give it a name, and we begin to go down these fields. We tell it what kind of construction there is. In this case, it was wood frame, trusses, 2x6, 24 inches on center. And then we want to know where the insulation is. And you'll need to refer to our guideline. And I'm going to scroll down here to page 13, where for different roof types, we describe where do we mean roof insulation is relative to that roof versus ceiling insulation. You kind of take a normal pitched roof. The roof insulation is underneath the roof deck, whereas, quote, the ceiling insulation is the blown cellulose or the bats that you might put right on the attic ceiling itself. And for flat roofs and cathedrals, we kind of show you what these different names mean. So we want to know what's the roof construction, where's the insulation, and in this case, since there is insulation in the ceiling, because we chose something here other than none, these fields get activated. We enter that there's 3 inches of insulation there. Therefore, we calculate the R value to be 10, and we gray that out to show you that it's a calculated value. If, when these were blank, you had entered the R value, this field would be grayed out, and it would show you then, based on the R value that you entered, we would calculate about how thick was it. These fields don't show up again for roof insulation because we said there is none, so you don't enter thickness and R value for those. You can enter a radiant barrier if there is one. We want to know what the roof material is, at the top. In this case, it's asphalt shingles that are a dark color. And then you enter how much of this roof space is above the units or the hallways. It's above, how much of it is above the units on the 3rd floor? Well, most of it is, and there's some above the hallways. There is none above the other floors because none of the other floors have a roof above it. But in some cases, you could have buildings where there's a roof above a unit on the 1st floor, but also it's a 3-story building and have a roof area above the 3rd floor. So that's why there are these, A1, A2s, because different buildings have different designs. We want to know the slope of the roofs. And then for the roof measures, it's basically, do you want to add ceiling insulation, roof insulation, which in a typical attic, it's on the roof deck. We said, yeah, let's analyze whether putting more insulation in this attic is cost effective, and therefore we have to say, well, what's the material and how much do we want to add to it that we would analyze? And I'll just go ahead and do floors at the same time. It's pretty similar to roofs. For floors, we can describe 2 types of underground floors, 2 types of what we call exposed floors, 2 types of interior floors, and then 2 types of floors that are above a crawl space. This is where I'll go over this in more detail Thursday, because I said I'd cover how you enter a slightly more complicated building on Thursday. Today, let's not get bogged down by some of this complexity. For our simple building that's on a slab, you enter a slab as a, quote, underground floor, but you call it so under an underground floor, it's concrete and it's a slab, and that makes the data entry pretty simple. You can see a lot of these fields go away. We say that there is no floor insulation here, although there is carpeting above that floor, 80%. And then again, like you've seen on these other forms, then we say, well, okay, how much of the floor area is associated with units or hallways on the 1st floor, since this is the foundation, and we said it's 2,400 on the units, 180 on the floor, so the total is 2,580. And for a slab, in general, for insulation, you can insulate the slab, or you can put on what we call exterior insulation or seal box insulation. There's diagrams, I think, in the guideline that point out what these mean relative to different foundation types. But the only one that's applicable to a slab is, do you want to insulate the slab? And we said, no, we don't want to consider that to be a measure. We don't do that measure on buildings, so we don't check that. So with that, I'll just unmute people quickly to see if there's any question then about roofs or foundations. All right, don't see any questions. So now we'll go into the systems. And so for HVAC systems, so first of all, multi in its current status can only address buildings with individual heating and cooling systems. So they cannot handle central heating systems, or what's probably rarer, central cooling systems. So what we mean by that is it's either units are heated by baseboard heaters, or they have their own gas furnace or their own heat pump or something like that. You can describe the heating systems, you can describe it as heating only, in which case you would only fill out the heating portion, or you can fill it out as cooling only. So for, say, a window air conditioner that goes through the window or the wall, it might only provide air conditioning, so you'd say cooling only, and then this part would be activated. Or in some cases, you could say it's combined system. So for example, if you had a gas furnace with a central air conditioner and an A coil on top of it, you might want to say that the configuration is combined, and then when you did that, you'd enter the gas furnace here with the A coil, the air conditioner description here, because it is kind of like one unit. Certainly a heat pump has to be combined, because a heat pump is a cooling and a heating piece of equipment all wrapped up in the same thing. For our example, I think if we go back to our building description, we said, whoops, wrong one. We said that the HVAC system, let me make that a little bit bigger. We said that the HVAC system is a 5 kilowatt baseboard, and there's a 1.5 ton and a 1 ton air conditioner in each of these apartments. There's no outside ventilation associated with them. The systems were made and installed in 1998, so that's going to impact these air conditioners. And I'll talk about the thermostat schedule in a second, but right now we're saying, yeah, the default schedule of 68 degrees in the heating mode, 76 in the cooling mode is fine. So if I minimize this and kind of go back to my audit then, what we did is we entered for System 1, we said, hey, that's the 5 kW baseboard heaters, it's heating only, and we filled out this information on the heating system. We chose no retrofits for the heating system. We're not going to rip it out and put in some kind of a heat pump or anything. And then we also used this for System 2, we said these are 1.5 ton air conditioners. This is how many of them are in the different units on the different floors. This is the characteristics of this air conditioner. No retrofits for it. And we described then the smaller window units as a separate system, again describing how they're distributed among the units and what their characteristics are. If we wanted to, we said the default thermostat schedule's okay, so we really didn't do anything there. But you can click on unit thermostat and override what the default settings of the thermostat is, and you can, if you check custom, all these fields come up and it says, well, what's the set point during the day, and what's the range of the day, and what's the set point during the night, and what's the hours of the nighttime. And then as a retrofit, if you wanted to, you could say, oh, we want to, put in a setback thermostat, and so you would describe that in this section. For our example, we chose just to use the default, so we didn't fill any of this out. And you can see that you can describe the thermostat settings and schedule for the units, the hallways, and then other conditioned spaces. What you cannot do is you cannot enter a separate thermostat schedule for the apartment on the lower floor versus the apartment on the upper floor. If one family kept their house at 70 and one kept their house at 74 during the winter, you would just have to average that and say the two apartments keep the house at 72. So you can put in different schedules, but you cannot put a schedule in for every unit. We decided that would be way too complicated. So that's kind of how you enter the HVAC system. I'll unmute and see if anybody has an immediate question.
Hey, Mark, this is Mike from BCD over in Little Rock. All our units, the majority of our units are central heat and air units. We don't, on apartments, we haven't seen any window units. We would just go ahead and enter it in like we would a normal house per apartment.
Yes, you would. You would. So, for example, you would be able to come in here, and if it was, again, so what you're saying, I think, is like a gas furnace with a central air conditioner, the A coils on top of the air handler, right?
Exactly.
Yeah. So what you'd probably do is you could either enter those separately. I would probably enter them combined and say it's combined. And then for the system type, it would be individual, but the equipment would be a central furnace for the heating. And although it's not showing up over for the cooling, so I can't show it to you on this form, but for the equipment type, there would be something about a central air conditioner. So you would call it a central furnace with a central air conditioner, and that would describe that heating system for what you're seeing, okay?
Okay,
and if that
but I would
was a heat pump, then you would actually just say it's a heat pump, and you have to enter it then on one form because the heat pump provides both heating and cooling. They're not separate.
Okay.
Okay? But yeah, I think what you're describing, you would enter that probably as combined, put it all, put the heating and the cooling system right here together.
Right.
Yep. Any other questions?
Yes. This is Wendy from BCD. So if I have 7 units, heat and air units that are combined in the building, for example, the large building that we talked to you about a little while ago, are we going to be able to put all that on here, or are we going to have to pick our primaries?
Yeah, I don't remember. I remember talking to you, but I don't remember the details of that building, so I can't answer it exactly. But let's just say that you had some units that had a. I'll keep it. I'm trying to think of it. So let's say you had some units that were bigger than others. So in some units you had a 2-ton heat pump, and in others you had a 1-ton heat pump. In that case, you would select System 1, and maybe you would say that's my 2-ton units, and those are only in units on the top floor. And then you would enter in System 2 the 1-ton heat pumps, and you would enter those just for saying, oh, those are applicable to the units on the first floor and the second floor. Mm-hmm. So you've got 4 different systems here that you can play around with. Now, if you have more than 4, then you are going to have to start combining some and kind of doing some averaging.
Okay.
But I think typically in most multifamilies, you don't have quite that big of a variety of systems. They're going to generally be about the same size. So let's pretend in a multifamily building you have these gas furnaces in each unit, but some of them were still 20 years old, and so they're 80% units, and in half the units they put in a new condensing furnace. So again, what you would do is call System 1 maybe the old atmospheric units, and maybe those are all the ones, on the ground floor, so you'd say there's 2 of those. But the new ones, you would enter as System 2, the condensing units, and you would say, oh, but those are only, there's 0 of them on the first floor, but there's 2 of them in the second and the third floor. So you can see you got 4 units to play around with, and you can divide them up different ways. But if you have more than 4, then you're going to have to kind of maybe artificially combine some. But generally, it's the efficiency that's important, not so much the capacity. So, if you had 8 of them and they all were different capacities and different efficiencies, well, you might have to combine 8 down to 4 by lumping 2 that have efficiencies that are pretty close to each other, and then just averaging out what the capacity was or something.
Okay, thank you.
Okay?
Yes, thank you.
All right, so I'm going to mute everybody again and go on here. So I'll rip through most of these others then and then get questions at the end. We only really have about 15 more minutes, so but we're almost done. So I'm going to go to infiltration. Infiltration, you can enter either as a whole building or you can enter by spaces. But probably the way most people are going to do it is to say, well, on average, the infiltration rate of the building is this. And then what we do is if you do it that way, we just take the same number and divide it and use the same number in each of the spaces. And you can enter the infiltration either as a natural air changes per hour, or if you did do some kind of a blower door reading or took a blower door test of the whole building, you could choose that method by checking this little circle here. This would be inactive, this would be activated, and you could enter what the blower door reading of the building was, which would be, a pretty big number, a 6-unit apartment, say, it would be maybe, 6 or 12, 10,000 would be, 10,000 CFM 50 or something. Now, we don't have time to go into how do you do a blower door measurement in a building, but that's the stuff that all the guys in Minnesota and Anthony Cox are all working on. You put multiple doors in the thing, and you have to synchronize them and run them at the same time and that kind of a thing. So number one, you enter the air leakage of the building. If you don't measure it, you're basically going to have to, the auditor's going to have to use their judgment as to what this number might be if you don't measure it. And if you estimate it, this is probably a number that you're going to go right to when you start doing calibrations, as that's the number that I had the least confidence in out of all the numbers I've entered into this whole audit. And that might be the first number that you tweak as you try to true up your model to utility data. If you want to air tighten the building, well then as a retrofit you would say, yes, I'm air sealing as planned, and you need to tell us how tight do you think you're going to get the building. Again, you can estimate the natural ACHs, or you can estimate what you think the blower door reading is going to be. And again, this is definitely an estimate because you don't really know how tight you're going to get the building, but you have to give us some guidance on that so that we can then calculate how much energy you might save by reducing the leakage rate from, say, 0.75 to 0.5 ACH. So you have to give us these estimates, even though you know that there's some uncertainty associated with them. Right now, there is a tab called Mechanical Ventilation. You can go to that tab, but it doesn't do anything, so just kind of ignore it for right now. We haven't activated that tab yet. And then water heating. Now, water heating, we can address both individual water heaters or central systems, but you can't have both. So if you have individual systems and start entering information on the individual systems, this central system tab kind of gets ghosted and you can't go to it. Or if when you first go to a building you enter a central water heating system, you won't be able to enter individual systems. You can only have one or the other. You can enter 4 different types of individual water heaters. So if you got some that are newer and some that are older, you can kind of divide them up that way. Basically, for this building, we said they were individual water heaters. So, as in a typical audit, you tell us what's the characteristics of the water heater, how many are there, what's the set point temperature, what's the size of the water heater. Ultimately, to do calculations, you want to know what the energy factor is and the recovery efficiency. If you don't know what those are, then you can choose here for the energy input method. One method is to say, well, I only know what year it was made. So if you say what year it is, then we estimate these for you. If you actually know what they are, you can say, hey, I know what the nameplate of these things are. You can choose nameplate, in which case there won't be a year field, and you can enter these numbers directly. So you basically enter the water heaters, and then here's the water heater retrofits. You can replace it. You can change the set point, put a water heater wrap, put in pipe insulation. And I forgot to tell you, so I'm just going to jump back here to the HVAC real fast. But for HVAC systems, the retrofits are generally, you can change the ventilation rate. That's usually not a retrofit done in most programs because it's usually really not associated with most equipment. But the measures are basically to replace it, tune it up. If it was a gas furnace, you could put a pilot light in as opposed to change the pilot light out with an IID, but that's not really done too much anymore either. So water heating, we just went over. Now lighting, here's what happens with lighting. So for lighting, you have to tell us, well, what's the power density of all the lights in the building? And to know what that number is, you need to read what we put in our guideline on page 16 here. We have a whole discussion of how do you estimate the lighting power density, and we give a table here for what typical power densities are for apartments and offices to kind of give you an idea of what the range and what a typical number should be. So you basically, and you can do this by the whole building or by the different zones. If you say you're going to do it by the whole building, we basically just apply the same number to each zone. And you also have to tell us what the usage schedule is. And again, if you go back to page 16 of our user guideline, we talk about that. Basically, the guideline says, a typical building is medium, but if everybody in the building leaves during the day, then call it low. But if it's a building where it's all elderly people and they all stay home during the day, then instead of it being medium, it might be high lighting schedule. But the guideline kind of talks a little bit more about that. And then you also tell us how much installed wattage is used for outdoor lighting. That typically is on during the night, okay? So if there's outdoor lights that aren't on, you wouldn't put it in here. Now, for the retrofits, if you don't want to do any lighting retrofits, you would not fill out this section down here. And right now, this section is called Lighting Systems, where we're going to change this name to Retrofit Measures to make it consistent with all the other forms. Somehow, when we did this one early on, it got a different name, so we're going to change that name. But the retrofits are described here. Okay? And there's always been a question about, well, gee, how does, do I have to install or describe all the lights in the building down here so that the audit knows what the internal load of the lights are and how it interacts with the heating and the cooling system? And the answer is no, because that's all handled right up here by knowing what this lighting density is. So in this section, all you're describing is what retrofits do you want to do to the lights that are installed in the building. And form's a little different, so I'm going to click on System. So Lighting System 1, it should be really Retrofit 1. Retrofit 1 is saying, hey, we want to replace the light bulbs with some CFLs. And there's 48 light bulbs that we want to do this with. the existing wattage is 75, and the new CFL will be 23. We also entered then a second lighting retrofit, which we called Lighting System 2, but it really, when we rename it, it's going to be Retrofit 2, was to put in some motion sensors on the lights in the hallway. So those are fluorescents, and what we're going to do, though, is we're going to put a motion sensor on so that they won't be on very often, only when people are walking down the hallway. So in lighting, you describe the retrofits in this bottom section that way. Now, we have a tab here for appliances, so similar to lighting, you got to tell us what the power density is for all the other appliances that are in the apartment, dishwashers, TVs, this kind of stuff. And again, there's some guidance in that guideline that I handed out that talks about how do you come up with this number. And right now, there are no retrofits for any of the appliances. So all we're trying to do is to kind of get a plug load so we know about how much other heating load there is, how much energy is being contributed to the building, internal load from other plug loads. Because the refrigerator, as a retrofit, is handled by its own tab. So for refrigerators, what you can do is you can enter up to 8 different refrigerators, and basically you say, hey, this is the existing refrigerator, and this is what I want to replace it with. And there's a lot of options here about how do you describe the existing refrigerator. Over here, you can tell us what year it was made so that we estimate how much energy it's using based on typical refrigerators made in 1998. But you can look up refrigerators in a database that we have. You can check that, hey, I know what the rating is, and you can enter those directly. So there's lots of different ways you can enter this. And then for the retrofit, you basically are going to tell us, well, what's the kilowatt hours of the new refrigerator? And we ask certain questions about the dimensions that, if you enter it all, we'd compare the dimensions of the replacement with the dimensions of the existing and tell you either it's not going to fit in the available space or hey, you're thinking of replacing the 20 cubic foot refrigerators with 15 cubic foot models, which might save energy, but the homeowners may not be happy that they're getting something that's a lot smaller. So we would throw up a warning maybe or two to say that this is going on. Now, the question that often comes up is do I have to enter the refrigerators? And the answer is no. You only need to enter refrigerators if you want to replace them. If you don't want to replace some of the refrigerators, you don't need to describe them up here and then not enter anything here. You don't need to do that. And if you don't want to enter or analyze any refrigerator replacements, then you just would not enter anything under any of these refrigerator tabs. The plug load of the refrigerators, as far as internal loads, is already considered in this appliance power density. So in a sense, the refrigerator form is like the retrofit that you might do for appliances. We just pulled it out as a separate tab because it really wasn't generally applicable to appliances. It's kind of like its own unique appliance, so we pulled it out as a separate tab. Plus, it worked better from a form-wise point of view. Well, look at that. It's 2:59, so I managed to get all that in 2 hours. I apologize that I talk so long, but there's no really great way of doing this other than me talking a lot about all this. So I'm going to unmute anybody to see if there's any more questions. And as you're thinking, if you have any questions, so what we basically have done today is you kind of got an overview for what multi looks like, where we're getting to, the calibration report, the measure report, and the package report. We went through rather quickly, but you kind of saw that, you enter an account, and then you do the audit. And to do the audit, you enter the audit form, the building form, and then all these other forms, which is pretty similar to other audit programs. And next week, and you kind of saw how for each, of these different building components, you do choose for that component, do you want multi to analyze a retrofit for that? And if so, what's the retrofit characteristics? And where we'll pick up then on Thursday is, I'll start by talking about a little bit about a more complicated building than the simple building that we entered today. But pretty much most of the time we'll be talking about entering utility bills, and then I'll go slowly through and show you how you do all these runs, calibration runs, measure runs, and packages. And in the measures, I'll show you how you do cost things out using the measure cost library and things like this. So that's kind of what we'll cover on Thursday.
Hey, Mark.
Any questions? Yes.
Yes. Do we get with our state monitor in order to have them get with you to get us this program, or do we just pay you directly?
Are you somebody at the
Michael
state level?
BCD. Pardon?
Pardon me?
This is Michael with BCD. We get our grant from the state.
Okay.
Sabrina.
Yeah, what you would want to probably do is talk to Sabrina at the state.
Okay.
And say, hey, we want to use this. And what we'll do is we'll talk to Sabrina, make sure, that's what she wants, and we'll get you set up then with a database just for the state of Arkansas.
Okay.
It might only have your agency in it, but that way you're kind of set up so that if other agencies in the future in the state want to start using it, we can add agencies and you're all in the same database.
That sounds great.
Now, right now, what you might want to do is just play around. Well, when we're done with the training, we'll send you a user ID and a password just to get into our current database so you can play around with it a little bit. But again, I wouldn't enter anything in there permanent because if we switch you to this other database, we won't be able to move anything over to that new database probably. So
Right. I was just wanting to practice and get familiar with it.
Right. Practicing right now, you won't need to talk to Sabrina. We can get you set up and play around with it. But after that, you say, "Yep, we really want to do this." Then we should get Sabrina involved and get a whole state database set up for you.
That sounds great.
Okay.
Thank you.
All right. Well, everybody, thank you for your patience. I know this is hard. I know sitting there for 2 hours and listening to somebody talk and looking at these screens isn't the greatest way of doing this, but it is cost effective to do it by a webinar. So I will send out a webinar information probably this afternoon for the webinar on Thursday. I don't think I'll send any more handouts, but if I do, I'll send that out to you. I will also send out the recording for this session, and then we'll just talk again on Thursday. Okay? So if there's no other comments or questions, all right, I'm going to turn the recording off.